All right, so we're going to start by looking at number one. They're asking us for the graph that represents our function g of x equals 1/2 times x squared. So what we're looking at is the parent function in all of these. So I'm going to highlight the parent function in yellow. So our parent function is x squared. Here, so there you can see that bottom one, and then there. So everything in yellow would be our parent functions, and now we're looking for the graph g of x that represents 1/2 times that x squared. So 1/2 is going to be a vertical shrink because my a value is 1/2, which is less than 1. So anytime you have a value less than 1, it's going to be a vertical shrink. So when I look through these options, I can see that we're talking here about a vertical shrink. In part B, they say that graph G is a vertical stretch, and that is incorrect. So I know my answer is not B. And C, again, they use vertical stretch, which is incorrect. And then part D, we're talking about a vertical shrink. So we know our options are going to be A or D. So looking at vertical shrink, we have to remember a vertical shrink takes your parent function, x squared, and pushes it down, shrinking it, which is going to make it wider. So if you look at A, my g of x is wider than my parent function, so my answer is A. Versus D, this is actually exemplifying a stretch because it's getting steeper. So my answer is A for number one. Number two, we're going to find the function g of x if g of x is translated 3 units to the left of f of x. So they're giving us f of x, and then we are going to translate 3 units to the left. So what I'm going to do is I'm going to show you two ways to do this. I'm going to show you the algebraic method, and then I'm going to show you what this looks like on a graph. So we'll start out with the algebraic method. We need to understand that 3 units to the left talks about our horizontal shift or horizontal translation, which is inside of the absolute value symbol. So this is going to be inside when you go to the left. So also, since it's 3 to the left, we're going to change the sign. Even though you think of going to the left as negative, you're going to be adding 3 to the inside. So our new function, g of x, will be the 3. Our a value, or the slope in this case, is going to stay x minus 5. But I'm going to go ahead and add that 3, which is translating 3 to the left. And then I just copy out that k value plus 2. And then just clean that up a little bit. In the inside, negative 5 plus 3 is negative 2. And that would be your answer. So our answer is C. So if you don't want to remember that what I highlighted here means adding 3 to the horizontal inside the absolute value, then you can always draw the graph. So I'm going to show you what that looks like on a graph. I will start by graphing this f of x function. So if I want to graph the absolute value, I have a shortcut that says that I can copy this ordered pair for my vertex, but always switch the sign inside. So it's going to be 5, 2. So 1, 2, 3, oh, sorry, to the right. 1, 2, 3, 4, 5, and then up 2. That's going to be my vertex, and my vertex has a slope of 3 over 1. So I'm going to rise 3, run 1, rise 3, run 1. So this is going to be my f of x function. So what I'm going to do is I'm going to take my f of x function and I'm going to translate it 3 units to the left. So I'm going to take my vertex and translate it 3 to the left. This ordered pair, I'm going to transfer it 3 to the left, and this point as well, 3 to the left. Let me erase that. And so now I have my new function graphed right here. So what I, again, need to do is write what that function is. So I'm going to look at my vertex as at 2, 2, and my slope is 3 over 1. So 3 for my slope, or the a value, stays out front. x minus 2, because when we plug in the positive 2, it becomes negative 2. You always switch the sign. And then you just write my y value positive 2 on the outside. So again, we get our answer is C. Number 3, we are again taking this function f of x, and we're going to write an equation for g of x, where g of x is a reflection on the x-axis. So I will show you both ways again. I'm going to show you algebraically and also on the graph. So when I reflect over the x-axis, it's following rules we know from geometry that say your x values are going to stay the same and your y values are going to become opposite or switch signs. So what I'm going to look at when I have f of x is the x value, which in this case is the horizontal, plus 0. That's going to stay. So my g of x, the x is going to stay. But the formula says we need to do opposite y. So if that y value is positive 3, it's going to become negative 3. But there is one more thing we need to remember. Whenever we're going over the x-axis, it's flipping our figure, in this case, right side up. So you also change the sign for the slope or for the a value. So instead of negative 1, it would become positive 1. And we don't typically write that. This would be our answer for g of x. It would be absolute value of x minus 3. So we get an answer of C. But again, I'm going to show you how to do that on the graph. So what we're going to do again is we are going to have our x and y axis. And then I'm going to graph this. So inside with x will be our x value, and then outside will be the y value for my vertex. So at 0, 3 is my vertex, and the slope, negative 1 over 1. So a value of negative 1 over 1 is going to tell me go down 1 right, down 1 left in both directions. This is my f of x. And now what I'm going to do is I'm going to reflect this over the x-axis. So this right here is our x-axis. It's going to be our line of reflection. So from this line of reflection, we can count to do our reflection. So I'm going to start with my vertex. It's 1, 2, 3 above the line of reflection. So when I reflect, it'll be 3 below. This point right here is 2 above, so it will be 2 below. Over here again, 2 above, so 2 below. And that right there is going to be our new function g of x. So all we need to do now is write the equation of that. So to write the equation of this, again, you look at the vertex, which is 0, negative 3. And then we look at the slope, which now is, or the a value, slope, rise 1, run 1. So I have a slope of 1. So I'm going to put that together into my function g of x equals slope of 1 out in front. I'm going to not write anything. Open your absolute value, and there's a 0 for my x, so I'm not writing anything inside the absolute value with x. But then I copy down the y. So I copy down negative 3 on the outside. Again, that is going to be the function that I create for number 3. That's how I get the answer of C. Number 4, again, we have our function f of x, and we're going to write an equation for g of x, given that we're going to do a reflection over now the y-axis. So for this one, we're going to show it algebraically. Algebraically, it follows a formula that we know from geometry. Anytime you go over the x-axis, our ordered pairs, our x's will change sign and the y's will stay the same. So based on this equation right here, if I'm going to rewrite it, what this tells me to do is to change the sign for my x value. So how it was negative 1, it's just going to become positive 1. There's no y value on the outside, so you just leave it alone, and this would be our answer. And unlike the x-axis, when you reflect over the y, the slope doesn't change. So this would be our answer, D. But again, I'm going to show you on my graph what this would look like. If I draw the x and y axis, and I start by graphing f of x right here. So f of x, again, an ordered pair, change the sign inside, so 1, and then there's nothing for k value or y value on the outside. So 1, 0 would be my vertex, and the a value is 1, so the slope would be rise 1, run 1, and then do the same thing in the other direction. And that'll be good enough for our sketch. So we're going to have this as our f of x. So what we're going to do is we're going to reflect this over the y-axis. So here is our line of reflection on the y-axis, and we can again count boxes. So for our vertex, we're 1 to the right, so when I reflect, it'll just be 1 to the left. This point over here is 2 away, so it would move over here. This one falls right on the y-axis, so we continue with that there. There is our new function, g of x. I just, again, need to write the equation for that. So we identify the vertex, which is -1, 0. Slope is still rise 1, run 1. So my new function, the slope, or a value, is not going to change. It's still going to be rise 1, run 1, so I won't put anything there. Inside the parentheses, or I'm sorry, inside absolute value is going to be a +1 because we always switch that sign, and then there's a +0 on the outside, which we don't write. So that is our answer. There it is for number 4. Okay, number 5, we're looking for the solution to this system of equations. So we are going to use either the substitution method, combination. I am going to use the combination method because that is going to be the most straightforward. We don't have to deal with fractions. So in order to solve this, I need to put these both in standard form. So this is good, this first equation, but this second equation is not in standard form yet. So what I'm going to do first is move over that 3x to be in front of 2y. So if I have -3x and I want to move it to the other side, I'm going to add 3x to both sides. So this new equation would be 3x plus 2y is equal to -7. So I rewrote this second equation so that these can both be in standard form. All right, so I'm going to go ahead and copy this down. My first equation, I'm going to write kind of small, try to write small. -3y is equal to 9, and then my new second equation, 3x plus 2y is equal to -7. So what I'm going to do now is I'm going to try to get the same number top and bottom, one positive, one negative, so that they will cancel. So I see a -6 right here. I'm going to multiply this bottom equation by 2 so that I get +6. That will cancel. So I'm going to go ahead and rewrite my equations. The top equation is going to stay. The second equation, I'm going to multiply by 2. So 2 times 3x is 6x. 2 times 2y is 4y. 2 times -7 is -14. And then using my combination method, next I'm adding down. So -6x and 6x, those cancel. -3y and 4y is 1y. 9 minus 14 is -5. So I have part of my answer so far, but I am not done yet. I need to go back and get x. So in order to do that, what I'm going to do is I'm going to take this and I'm going to plug it into one of my original equations, and I'll just go ahead and use this top equation right here. So I'm going to plug y is -5 back into this top equation. So -6x minus 3 times -5 is equal to 9. And then I'm going to solve. -3 times -5 is +15. Subtract 15. 9 minus 15 is -6. Then dividing both sides by -6, I get x equals 1. So my ordered pair, 1, -5. My answer is B. When you're taking your exam, a good thing to do would be to get your answer and plug it back in to make sure it's true for both equations. So that would be a good way to check your work. All right, number 6, we are solving equations. So what we're going to do is we're going to figure out where they made a mistake. So let's start with solving this. So step 1, -9x. -9 times -4 is 36, and that's equal to 7x plus 14. So far it looks pretty good. I'm going to go ahead and copy that down over here just so I have some room to show my work. And then I'm going to go ahead and solve. So it looks like they moved over the x to this side. So when I do that, I would subtract 7x to both sides. These are the same sign. I'm going to add and keep the sign. and I can already see that's where they made their mistake. So right here, they should have negative 16x. So they made a mistake right here at step 2. So my answer is A for number 6. Number 7, we're going to find the length of the longest side if a rectangle has a perimeter of 126, and the length is as follows. So they're giving us the length, they're giving us the width, and then they tell us that the perimeter is 126. So we have to remember perimeter means the sum of all of the sides. So we're going to go ahead and find the sum of all of the sides. Some of you are familiar and comfortable with using this formula for perimeter of a rectangle, but I'm not going to do that. I'm just going to take the long way so that we can all see exactly, pretty straightforward what's going on, and we don't have to memorize the formula. So when I'm given a rectangle, I know I'm going to be adding 4 of these sides together to find the perimeter. So far they're giving us 2 sides, but since it's a rectangle, we need to know that opposite sides are going to be the same. So this is negative 9x minus 4, and this side's negative 4x plus 2. So what I'm going to do is I'm going to add all of these and set it equal to 126. So when I do that, it will look like this. I'm just going to add all the sides. I know I'm going crazy with these parentheses. I'm just using parentheses because of the negatives. So what I'm going to do is I'm going to combine like terms. Oh, sorry, that's equal to 126. So I'm combining like terms. I'm going to combine all of my x terms. So I teach my kids to just not even write this equation. Like this one that I just wrote, maybe we don't even need to write that. That's too much writing and it gets confusing, especially with the negatives. So if we just look at this figure, we're going to add the x terms together. So it's going to be negative 9 and negative 9x to give us negative 18x. And then you have negative 8. So negative 18x and negative 8x will give us negative 26x. And again, if you just combined all your x terms down here, they're all negative, so you would add them, keep the sign, negative 26. Now we're going to go and look at our constants. So I have 2 and 2 is 4. Negative 4 and negative 4 is negative 8. So we have negative 8 plus 4, and we get minus 4 for the next part of our equation. Again, you would have got the same thing if you would have combined your constants down here. All right, again, this equation, it's going to be equal to the perimeter they tell us is 126. So now I just have an equation to solve. I'm going to add 4. Get negative 26x is equal to 130. Then I divide both sides by negative 26. And 130 divided by negative 26 is negative 5. But we're not done. They're asking us to find the length of the longest side. So hopefully on your exam, you aren't going to choose C, because that's not what they're asking us for. They're asking us to find the length of the longest side. So what I'm going to do is I'm going to take negative 5 and I'm going to plug it into the longest side. So for negative 9x minus 4, I'm going to replace x with negative 5. So I get negative 9 times negative 5 is 45, and 45 minus 4 is 41. So the longest side has a length of 41. Number 8. Victor paid $110 to get his car repaired. The total cost for the repairs was the sum of the amount paid for parts and the amount paid for labor. So he was charged $60 for parts and $10 per hour for labor. So when he buys parts, this is going to be one time. He's going to buy parts one time because it doesn't say anything about that reoccurring. But we do need to understand that it's $10 per hour for labor. That is something that will be reoccurring. So this is going to be your linear equation. We have $60 for parts and $10 per hour. So And you can switch this order, that's fine too. So one-time fee plus that reoccurring $10, and he's gonna pay a total of $110 to get that car repaired. So how long did it take to get his car repaired? We wanna know how many hours. We're gonna solve for X. So I'm gonna subtract 60. I get 10X is equal to 50. Divide by 10, X equals 5. So it's gonna take 5 hours for his car to be repaired if he spent $110. Number 9, we are solving for X. This is going to be a system of equations. I'm again going to use the combination method where I'm going to cancel out one of these variables to start. So I'm looking at 6x and negative 3x. I can cancel those out if I multiply this by 2, giving me the negative 6x to cancel with the positive 6x. So I'm going to start by rewriting each of these equations. It's going to be the top equation, that's not going to change. And then this second equation, I'm multiplying 2 to each of the terms. So now I'm adding down, those cancel. 4y is equal to negative 8 plus 16, which leaves us with positive 8. Then divide by 4, and I get y equals 2. But they want me to find x, so I'm not done. I'm going to take that and plug it back in to one of these original equations. I'll go ahead and just use the top equation. 6x plus 2y equals negative 8. And I'm going to go ahead and replace y with 2 right here. So it'll be 6x plus 2 times 2 is equal to negative 8. 6x plus 4 is equal to negative 8. And no, we're good. 6x is equal to negative 12. Divide by 6. Negative 12 divided by 6 is negative 2. So my answer is A. Number 10, we're considering the following system of equations, and they're asking us to describe the graph. So whenever they ask you to describe the graph, there's different ways you can do it. We can look at these and put them in slope-intercept form, or we can try to solve it. Okay, so when we solve this, if we get an ordered pair for an answer, it's going to be exactly 1 point. So that would be if we get an ordered pair as an answer. If the lines don't intersect, this would be if we get parallel lines. And that would be if our x and y's canceled and left us with a constant. And then intersect at infinite number of points means they're the same line. And that's when everything cancels out in both. There's no such thing as intersecting at just 2 points. Okay, so what I'm going to do is I'm going to try to solve this. But this is not ready to be solved because this order on my second equation is a little bit messy. So I'm going to keep my top equation, and then my second equation I'm going to rewrite. So I'm just going to bring the negative 8x first, and then positive 2y is equal to negative 2. Okay, so now I have both in standard form. The x's are aligned, the y's are aligned, and I'm going to try to solve this. So I'm going to go ahead and multiply this top equation by negative 2. So that I can have a positive 8 and negative 8 to cancel out. So when I multiply the top equation by negative 2, I get 8x minus 2y is equal to negative 6. So then when I add down with my second and first equation, those cancel, and I'm left with 0 is equal to negative 8. Whenever this happens where your x and y cancel and you still have this constant left over, it's no solution. This makes no sense. You can't solve this, and 0 is not equal to negative 8, so it's no solution. And what this means is that these lines are parallel, and they are never going to intersect. So your answer is C. Okay, number 11, we're going to find our slope of these home phone sales. So when I find the slope, I am going to be calculating rise over run. So some of you are going to be able to see that just by looking at the numbers, but for the majority, what we're going to do is we're going to use our slope formula, which looks like this: y2 minus y1 over x2 minus x1. And you can use this formula anytime you have 2 points. Since we have 2 points, very clearly 1 comma 600 and 5 comma 200, we can go ahead and use this formula. So I'm going to label these x1, y1, and x2, y2, and then plug them in. So y2 minus y1, so 200 minus 600 over x2 minus x1. So 200 minus 600 will give me negative 400. 5 minus 1 is 4. Negative 400 divided by 4 is negative 100. So my slope is negative 100. And that makes sense because this line is falling. It's a negative slope. So we definitely know our answers weren't B and D. Number 12, 13, and 14, they're just asking us to identify the function family. So for for 12, this is a parabola. This is going to be our quadratic function. So my answer is B for number 12. Number 13 is our V-shape absolute value function. So we're going to say C absolute value for number 13. And then number 14 is a straight line. This is A linear. Number 15. We are given that f of x equals absolute value of x is a parent graph of this g of x here. We're going to describe the transformation. So we can start with the 1/2 here out in front. Whenever your a value changes, so the a value is going to be the number out in front of the absolute value. That is going to talk about a vertical stretch or a vertical shrink. Every single time, that is what that a value out in front means. Okay, but since this number is less than 1, it is going to be a vertical shrink. Okay, it's a vertical shrink because this number out here is smaller than 1. So far, I'm going to circle C for shrink. You know what? They're actually, let me take a step back. 15, 16, and 17 is kind of doing that. So let's look at 15. We're kind of answering that already. The graph of G is a vertical shrink. All right, we got to make sure we're reading the question correctly. My bad. All right, so we're going to say C for number 15. Shrink because of that 1/2 out in front. All right, then if we look at positive 1 right here, positive 1 on the inside we know is a horizontal, meaning we're going left or right. Because it's positive, you switch, think of the sign switching, it's actually like a -1, which tells us to take this unit, this 1 unit to the left. We're going to go left 1 unit. So 1 unit left. We're going to pick E for this one. Okay, and then the last part, translating 5 units. They're talking about that -5 over here. So -5 on the outside means we're going to go 5 units down. Translating 5 units down. So I'm going to choose B. Translating 5 units down. Okay, so that's what we have going on in number 15, 16, and 17. Number 18 through 21 has to do with this graph that they give us up here. Okay, so we're going to use the, not absolute value, the quadratic right here that they give us, and then we're going to figure out which A through D go with each of these graphs 18 through 21. So again, our parent function is here, and we're going to compare that. So number 18 is flipped upside down. So automatically we should know that that just means A. It's -x². It's flipped upside down, so that A value was negative. So we have A for 18. Number 19 took our vertex 0, 0 from our parent function and shifted this 3 to the left. So anytime you go left or right, again, that's happening inside our parentheses. So 3 to the left, remember when you're inside parentheses, you're actually thinking of this as plus 3 because you change the sign inside. So that would be b x plus 3 squared. Again, 3 to the left, you switch the sign, it becomes positive 3 inside. Number 20 takes our parent function and moves it up 3. So again, up 3 would talk about the k value or the number on the outside of parentheses. So that's how we get dx squared plus 3, because when you go up 3, it talks about this value out here, not in parentheses. And then our last one, this goes right 3. So again, when you translate right 3, you are going to think about this being inside of our parentheses. You switch the sign, so we're actually thinking about minus 3 inside parentheses. That's how we get x minus 3 squared. So C would be our answer for 21. 22. We're going to let f of x be x minus 2, and we're going to write an equation for g of x if g of x is translated 10 units to the left. So I'm going to show you both ways. I'm going to show you algebraically, and then I will show you on a graph. So I'm going to need to understand that 10 units to the left tells me inside parentheses, I'm actually going to be adding 10 inside parentheses. So far, in our f of x function, there is no parentheses, so we can go ahead and add in our own. It's going to be x, and then we're going to add 10 for that translating to 10 to the left, minus 2, and then all we need to do now is clean this up. It's x plus 10 minus 2, which leaves us with x plus 8. Okay, but maybe it's not going to be that easy on our test, so we should know how to do it to check our work algebraically. So we are going to start now algebraically by plotting x minus 2. I have a feeling I'm going to need a big graph for this one. Okay, so x minus 2, I'm going to start down 2, and then I have a slope of 1 over 1, and I'm going to graph this. This is going to be my f of x, and I'm just going to do like a quick dashed line to represent f of x. Maybe I need a few more. Okay. So what I'm going to do is I'm going to take all of these points and I'm going to translate them 10 units to the left. I'm going to use a red marker for this. So 10 to the left, we'll put this one way over here. This one. And then 10 more. 10. I'm moving each of these over 10 to the left. So we can remember that in a translation, our slope is not going to ever change. That's why if we did up 1 over 1, we can just continue to do that here, or simply just count, all right, we're taking these 10 units, okay? So here is my new line. This is going to be my transformation g of x. So what I need to do is I need to write an equation of g of x. Remember, the number in front of x will be our slope. We have a slope, rise 1, run 1. So my slope is just 1, so x, 1x. And then my y-intercept is going to be this number out here on its own, 1, 2, 3, 4, 5, 6, 7, 8. So here is my function, g of x. So you can do that either way, and you get the same answer, x plus 8. Number 23, we're going to select the ordered pairs that are solutions to the equation. So whenever we have a line, the solutions are all of the points infinitely that lie on the line. So we're looking for the points that lie on the line. Those are going to be our solutions. So if I plot -1, -4, I see that it is on my line. So yes, it's a solution. negative 1 comma 0 is not on the line, not a solution. 0 comma negative 1 is on my line, a solution. 2 comma 5 is on the line, it's a solution. And then 2 comma 1, not on the line, so not my solution. Number 24, they're giving us the graph of a system of equations, meaning two equations. So for part A, they want us to write an equation for f of x. So we're first going to look at f of x, which is labeled here, and we're going to write an equation for that. So when I write an equation, I'm going to remember that I'm going to use the formula y equals mx plus b. So what I need to do is I need to find the slope and I need to find the y-intercept. And then of course this is f of x instead of saying y. So f of x is equal to my slope, which if I pick two good points, I can choose this point and this point. Rise 2, run 1. So I know my slope is going to be 2. And then my y-intercept, the number by itself, is my number right here where my line crosses the y-axis. I get 2x minus 4. There's my f of x function. I'm going to do the same thing now for g of x. So g of x, we are now talking about this line. I'm going to write an equation for that. Again, the number in front of x will be our slope. Rise negative 1, run positive 1. So my slope is negative 1x. Because this line is falling, it should be negative. And then my y-intercept, the number by itself, will be where the line crosses the y-axis, which is at positive 5. So there's my g of x equation. For part C, they want to know the value of x where f of x minus g of x equals 0. So what they want to know actually is just where these are the same. Where is your value of x for f of x and g of x the same? In other words, where are they equal? So if I want to move over g of x, it kind of looks like this. You don't really need to write this, but I'm just showing you the reasoning. 0 plus g of x is g of x. So this is what they're actually asking us for. For what value of x are these equal? So what you do is you look to see where the lines intersect. So those lines are going to intersect right here. At what value of x? 3. So my answer is x equals 3. Part D, they want to know for what value of x, values of x, is f of x equal to 6. So what they're asking us for now is to figure out where is our f going to be equal to 6, meaning what's our x value when y equals 6. So what we can do is two different things, okay? I'm going to show you the algebraic way. The algebraic way would be to look at your f of x equation and just set it equal to 6 because they want to know when it equals 6. So then I add 4, 10 equals 2x, divide by 2, sorry it's getting a little sloppy, 5 equals x. So my answer will be 5. Okay, but what if you wrote the wrong equation in part A? You wrote the wrong equation to start with, the whole thing's going to be wrong. So let me show you how to read the graph. So what you need to remember is when you have this number outside of parentheses, so x is inside, this is outside parentheses, think of this as our y value. So what we're going to do is we're going to go to our y-axis and we're going to go to 6. So I'm going to go to y is 6, and then I'm going to find my f of x function. My f of x function was the pink function over here. So right here I have when f of x equals 6. So what you're doing now is just looking to tell me what my y value is, or I'm sorry, what my x value is. Down here, it's 5. So x equals 5. Again, y equals 6. That's my y value. Find your f of x function. It's right here at x equals 5. So my answer is x equals 5. All right, this time they're asking us to find f of 4 and subtract that by 2 times g of 1. So what I'm going to do now is I'm going to find f of 4 f of 4, this time they're giving you the x value. So if algebraically you want to do this, I'm going to show you both ways again. Algebraically, this would mean to take 4 and plug it into this equation. So it would be 2 times 4 minus 4. 8 minus 4 is 4. So I know f of 4 is going to be equal to 4. That's how you can do it algebraically. But again, if you wrote the wrong equation to start with, the whole thing will be wrong. So I'll show you how to read the graph. F of 4, because 4 is on the inside of parentheses, it's talking about our x value. So what you would do is you would go to 4 on the x-axis and find your f function. It's here at y equals 4. Again, 4 on your x-axis means y equals 4 for my f of x function. So again, another way you can find 4. Okay, they want us to subtract 2 times g of 1. So the next thing I'm going to do is I need to find g of 1. So algebraically, you could take 1 and plug it into this equation that we made, and it would be negative 1 plus 5, and negative 1 plus 5 is 4. So my answer here again was 4. Again, if you wrote the wrong equation, it's going to be wrong. So to read the graph, this is going to be my x value inside parentheses. So I go to my x-axis at 1, and this time I'm talking about my g function. So I go to 1 on my x-axis and find the g function. It's up here. So it's right here at 4, at y equals 4. So that's another way you could do it. But I'm not done. They want me to find f of 4 minus 2 times g of 1. So I found f of 4 was 4, and I'm going to subtract that by 2 times g of 1, and we found that g of 1 was 4. 4 minus 8 is negative 4. So my answer for E is negative 4. Number 25. This following graph shows us the amount of money we're receiving per hour, and we are told to write an equation of this line. So what I'm going to do is I'm going to go ahead and put 0, 0 on here for my y-intercept, or for my where this crosses. In this case, it's the origin. So when I write an equation of the line, I know this is not enough room, so I'm actually going to do part A down here. I have this equation that I want. Part A, y equals mx plus b. They're actually already giving us b. B is my y-intercept, so we already know that b is going to be plus 0. So it's going to be y equals some slope x plus 0. So now what I'm going to do is I'm going to find my slope to finish this equation. So when I'm given 2 points like this, I can find the slope by using the formula. So my formula is going to be m equals y2 minus y1 over x2 minus x sub 1. And then I'm going to plug in my points. So 2, 17 will be 1 point. I'll call that x1, y1. And then 0, 0 could be x2, y2. And then I just plug in y2 minus y1. So again, y2 minus y1 over x2 minus x1. 0 minus 17 is negative 17. 0 minus 2 is negative 2. And I get positive 17 over 2 for my slope. So in other words, you can also say 8.5. So my equation is going to be y equals, let me erase these underline, 17 over 2x plus 0. So let's clean that up. I'm going to rewrite that over here. Y equals 17 over 2x is a good answer. Or you could say y equals 8.5x. Either one of these is perfect. Okay, so the next thing they want us to do for part B is to interpret the slope. So when we interpret the slope, we are going to talk about the unit rate. So we're going to mention the slope, which again is y over x, rise over run. In this case, if we look at what the graph is giving us, y is going to be the money earned. So it's going to be the money earned for our y. And our x is going to then talk about time, so hours. And we're going to talk about per. That word per is going to be our slope. So the amount of money, talk about the y first, the top of the fraction, the amount of money earned increases. It's increasing because it's a positive slope. It increases 17 over 2, or 8.5, so $8.50. And these are what, dollars? Well, we know that that's dollars. And we have to say each hour or per hour. I actually want to write per hour. So when you interpret the slope, you kind of use this as a guide. It's going to be your y value. So in this case, the money earned, and it's increasing because of positive slope, or just look at the graph, you can see it's increasing. And then you mention your answer, and then per hour, whatever your x is, will be last. So the amount of money earned increases $8.50 per hour, or 17 over 2 of $1, which, okay, that's fine. $8.50 makes much more sense. Okay, number 26. We have 2 high schools in the district planning a trip to New York City. Your high school rents and fills 3 vans and 4 buses with 112 students. So far we're talking about 3 vans, 4 buses for 112 students. The other high school rents and fills 2 vans and 8 buses with a total of 192 students. There's no open seats, and now we are going to define variables. Well, we don't really know what they're talking about. If you kind of read ahead, how many students can a van carry, how many students can a bus carry? Once you read these questions, hopefully it is very clear what it is they're asking us. We're talking about students in a van, and we're talking about students in a bus. So those are going to be our variables. We can let x be number of students that can be in a van, and we'll let y be the number of students in a bus, since those are the 2 things they're asking us for, if you weren't able to catch that up here. All right, so what we're going to do is we're going to create an equation to model each situation. So we're going to create 2 equations. We have one for this first sentence that talks about our high school. So for our high school, there's going to be 3 vans. So 3 vans, meaning 3 with some number of students in each of them, plus 4 buses, so 4 times however many students are in each bus, for a total of 112 students. So I went ahead and just put this equation, this sentence, into an equation. And then I'm going to do the same thing with this next part. We have the other high school for our second equation, where we have 2 vans, so 2 times however many students are in a van, and 8 buses, so 8 times however many students are in a bus, for a total of then 192. So that second sentence, talking about the other high school, was our second equation. So that's going to be our system. Now they're asking us to figure out, okay, well, how many students, and how many students in the van, how many in the bus? So they're just asking us to solve this. So what I'm going to do is I'm going to look at each of these, and I'm going to try to cancel out a variable. So I have a 4y and a 8y. So in order to cancel out maybe these y's, I can multiply by a -2 to the top. So I'm going to start by copying this down kind of small. And I want to get rid of y. I think that's going to be easier. So I'm going to multiply the top equation by -2. And then I'm going to rewrite it here. Underneath, it's going to be -6x minus 8y is equal to 112 times 2, which is going to be -224. And then I'm going to add down. 2x minus 6x is negative 4x. These are going to cancel. 192 minus 224 leaves me with negative 32. Dividing by negative 4, negative 32 divided by negative 4 is 8. So far I know that a van can carry 8 students. So I can go ahead and answer part C. 8 students in a van. Okay, but I again need to continue answering. I need to now know for a bus. So I'm going to find y, because y is the number of students in a bus. By taking that, plugging it into one of these original equations, I'll just go ahead and use the top equation. And I'm going to replace x with 8 right here. So it'll be 3 times 8 plus 4y is equal to 112. This is 24. And I'm going to subtract 24. 4y is equal to 88. Divide by 4. 88 divided by 4 is 22. So I know that each bus can carry 22 students. And that's how we would do number 26. Okay, 27, we just have an equation to solve. So I'm going to do my order of operations. I need to actually get rid of these parentheses first. It's not really order of operations. I shouldn't have said that. I'm tired. Okay, negative 2 times negative 6x is positive 12x. Negative 2 times negative 6 is positive 12. And that's equal to negative 2x plus 2. So that's my first step. I need to get rid of parentheses. Next thing I'm going to do is combine like terms. So I'm going to combine 4 and 12. That's going to give me positive 16, and I'm going to copy down the rest. Next step, I'm going to move this 2x to the other side by adding 2x. 14x plus 16 is equal to 2. I'm going to move the 16 to the other side. 2 minus 16 is negative 14. Divide by 14. Negative 14 divided by 14 is negative 1. So my answer is x equals negative 1. Number 28, they're asking us to graph the system and identify the solution. So when we're doing this, we're going to look to see where the lines intersect. Where do those lines intersect? That's going to be their solution. So for this first line, pretty straightforward. It's already in slope-intercept form, so I'm going to start at 4 on my y-axis, and I have a slope of negative 3 over 2. So from this point, I'm going to rise negative 3 and run 2. And I'm going to make as many points as I possibly can across my graph. And this is going to be that first equation. Okay, the second equation is not necessarily ready to be graphed. So what I'm going to do is I'm going to put this in slope-intercept form, y equals mx plus b. So I'm going to get y by itself by moving over this x, by adding 4x. 2y is equal to 4x minus 20. Then my last step to get y by itself is to divide everything by 2. And I get y equals 2x minus 10. So I'm going to go ahead and graph that on my graph. I'm going to start down 10. Which I'm going to go ahead and make some more marks. My graph wasn't big enough. Okay, so I'm starting down 10, and then I have a slope of 2 over 1. So from this point, I'm going to rise 2, run 1. Rise 2, run 1. And I can already see right here is where my lines are going to intersect. So these lines intersect right here at 1, 2, 3, 4. Common negative 2. So my solution is 4 comma negative 2. Number 29, we're going to solve the system using substitution. So this is already set up and ready for us to go. They isolated the variable. All we're going to do is we're going to take this part, negative 4x minus 8, and we're going to substitute it in right here for y. So I'm going to copy down negative 4x minus 5, but I'm replacing y with negative 4x minus 8. And just copy down the rest of the problem. All right, now I'm going to get rid of my parentheses by distributing negative 5. Negative 5 times negative 4x is positive 20x. Negative 5 times negative 8 is positive 40. Then I'm going to combine like terms. Negative 4x and 20x gives me 16x. I'm going to subtract 40. 16x is equal to negative 48. Divide by 16. Negative 48 divided by 16 is negative 3. But I'm not done. I need to find y because it is a system of equations and I always have an answer, my ordered pair x comma y. So I'm going to take negative 3, I'm going to plug it in to that top equation. It doesn't matter which one you pick, but that top equation is going to be much easier. So I'm again replacing x with negative 3 because I know x equals negative 3. So y equals negative 4 times negative 3 minus 8. Negative 4 minus negative 4 times negative 3 is 12 minus 8, and I get y equals 4. So my answer is going to be the ordered pair, negative 3, comma 4. Number 30, we are going to compare each function with the parent function and state whether it contains horizontal or vertical translation. That should say contains horizontal or vertical translations. So horizontal translations, we remember, happen inside of the parentheses or the absolute value symbols. That's going to be our horizontal. The vertical translations are the numbers that add and subtract on the outside of the absolute value or parentheses. So right here, I have 3 times x squared minus 1. So if we did have parentheses, they're just imaginary parentheses. There's a plus 0. So there's nothing happening inside parentheses. So there's no horizontal translation. But the minus 1 on the outside tells me to move down 1. This is a vertical translation. Vertical translation. And let me write that for you guys. Horizontal, again, it means go left or right. And then vertical means go up and down, just to clarify that. Horizontal, left and right, and then vertical, up and down. All right, so this one, there's actually no translation happening because there's no number adding inside absolute value and there's no number adding to the outside. So this is neither. Right here, minus 4 is telling us to move or translate 4 to the right. So again, inside, that's going to be our horizontal translation, minus 4. And then the plus 5 on the outside tells us translating up 5, meaning it has a vertical translation. So it has the horizontal here and the vertical translation here. And then for v of x, this last one, plus 2 inside the absolute value means to move left 2. That is going to be a horizontal translation because, again, it's inside telling me to go left. So horizontal. Number 31, we're going to write an equation of the line of fit. That just means write an equation. So in order to write an equation, given this information, I can go ahead and copy down 2 ordered pairs from the table. It does not matter what you choose. So I'm going to choose this and this. So I have 0, 45 and 1, 96, and I'm going to write that equation. So the first thing I'm going to do is I'm going to find the slope, y2 minus y1 over x2 minus x1, and I can label these make it more clear, x1, y1, x2, y2, and then plug them in. So y2 is 96 minus 45 for y1, and then x2 is 1, x1 is 0. So it's going to be 96 minus 45 is 51, 1 minus 0 is 1, 51 over 1 is 51. So far I know my slope is 51. So what I'm going to do is I'm now going to take one of these ordered pairs and plug it in with this slope. So I'm going to choose this ordered pair to plug in to my point slope formula. That's the next step. So first y always stays. Then you take y1 from your ordered pair. It's 45, so this is going to be minus 45 is equal to my slope, 51. Parentheses, open and copy the first x. x1 will be replaced with 0 from my ordered pair. Then I'm going to distribute, and I get 51x. 51 times 0 is 0, so I'm just not even going to write anything down. Or I guess I can. 51 times 0 is 0. And then my final step is adding 45. And I get y equals 51x plus 45. So that would be the equation of the line. Some of you looked at this and said, oh, 0, 45, that means y-intercept, and you just plugged it in. That's fine too, but I just want to make sure everyone knows how to do the work, just in case they don't give you the y-intercept. All right, we're going to interpret the slope and y-intercept in this situation. So to interpret the slope, again, we're going to kind of follow the pattern y over x, where it talks about per. So what this means is the amount of money or the cost. So we'll just say the cost increases. So again, cost is my y, so I mentioned that first. It's increasing because it's a positive slope. It increases what amount? So we just found my slope. It's $51 each year. And that's after 2010. So that's how you would interpret the slope. The y-intercept, which I ran out of room, the y-intercept means that it costs $45 when? In 2010. So that's going to be my y-intercept. Okay, predict the cost of prom tickets in 2015. So they're talking about the year 2015, so they're giving us x equals something. X talks about years after 2010. So if this is 2015, we have to let x equal 5. So all we're going to do is we're going to use our equation, and we are going to replace x with 5. So y equals 51 times 5 plus 45. 51 times 5 is 255. 255 plus 45. Maybe we could show that work. And I get 300 as my answer. So predicting the cost of prom tickets in 2015 would be $300 in 2015 if we were to use that equation. All right, moving on to 32. We're almost done. 32, we're going to solve the system of equations. So this is a 3 by 3. I'm going to erase this just in case it gets into my way. What we're going to be doing is we're going to follow those same 3 steps. We're going to eliminate a variable, we're going to create a system, and then final step, plug it back in. So for my first step, I'm going to eliminate one of my variables, and I'm going to do it twice. So when I look at this, I'm looking at the x's, the y's, the z's, and I don't know. I'm thinking the y's is going to be less work. So I'm going to eliminate the y's. And I'm going to do that 2 times. So I'm going to start with my top equation and my second equation. So equation 1 and 2, I'm going to write those down. And I'm going to try to eliminate y. So in order to do that, I would have to multiply this top equation by -3. So when I do that, this gives me -9x minus 3y minus 6z is equal to -9. And then I'm going to add down. This is -5x minus 3z is equal to -5. So that is part 1. I just need to do it one more time. So I already used equations 1 and 2, so we can now use equation 1 and 3 or 2 and 3. I'm going to go ahead and use equations 2 and 3. So I'm going to now do that again. I'm going to copy my second equation. Let me not let that confuse us. 4x plus 3y plus 3z equals 4. And then my last equation. And we are going to go through and eliminate the same variable. We're going to eliminate y. So in order to do that, I would multiply this top equation by -2 so that I get the -6x to cancel out here. So this is going to be -8x minus 6y minus 6z is equal to -8. Then I'm going to add down, and I get -4x minus z is equal to -4. So what I just did is I finished step 1, and I'm going to move on to step 2 using these two equations that I just came up with. So step 2 is to create your new system of equations. This time it's going to be a 2x2, and we all should remember how to solve that from Algebra 1. So here's my new first equation and my new second equation based on what we did in this first step. So what we're going to do is maybe we even just ignore everything else for a second. We should know how to solve this thing. We should know how to solve for x and solve for z, and we're going to use combination. So when I have this, I want to easily get rid of z in this case. So I have a -3 on the top. I need a +3 down here. So to get a +3, I'm going to multiply this entire equation by -3. And I'm going to go ahead and rewrite both of these equations. The top one is not going to change. The bottom one is going to become +12x plus 3z is equal to 12. I'm going to add down. This is 7x. Those cancel, and that's equal to 7. And then when I divide by 7, x equals 1. All right, so I have the first part of my answer. I'm going to take that, and I'm still on step 2, ignore everything else. I'm going to take x equals 1, I'm going to plug it into one of these two equations from my new system. I'm going to just go ahead and use the top equation, and I'm going to plug in x is 1 right here. So it'll be -5 times 1 minus 3z is equal to -5. This is -5 minus 3z, -5. I'm going to add 5. -3z is equal to 0 because 5 and -5 become 0. So I divide by 3. 0 divided by any number is 0. So I have two answers. That's step 2. Step 3 is I'm going to take those answers from step 2 and plug them in using one of my original equations. So we're plugging in our answers from step 2 to an original equation. So that's going to be one of these first 3 that we started with. So I'll just go ahead and use the top equation, and I'm going to plug in what I have. So that top equation, 3x plus y plus 2z is equal to 3. I'm going to replace x with 1, and I'm going to replace z with 0. So it'll be 3 times 1 plus y plus 2 times 0 is equal to 3. 3 times 1 is 3. 2 times 0 is 0. That can just be gone. And then subtracting 3, 3 minus 3 is 0. So anytime I have this system, I need 3 answers, and I typically write them as an ordered pair, x, comma, y, comma, z. So I got x is 1, y is 0, z is 0 for my answer. Oh man, we're on our last problem. Okay, for this last one, we are going to use the graph below to find the total, or to answer the questions. All right, let's not overcomplicate this. They don't want us to write an equation. We just need to know how to read this. So if we say for every 30 hours, the canoe rental is $2, what are they trying to say? Maybe from this ordered pair. So for every 2 hours, it's going to be $30. Well, if you look from here to here, you get 2 comma 30. So this just means after 2 hours, it's going to cost $30. That's what this means. But let's say another 2 hours passed. So if I'm over here at 4, let's write down this ordered pair, 4 comma 40. So 2 hours passed, but did you have to pay $2, or how much more was that? It was $10 more. So it's false. It's no, not every 30 hours. Oh, I see what they did. Every 30 hours. Okay, no. They switched these. 30 hours would be way over here. 30 hours, and then $2 would be like over here. If we follow this line, no way is it going to pass through this point over here. So no, that is just so wrong. So wrong. For 2 hours, it's $30. They had those switched, so don't do that. Okay, for every 5 hours, the canoe rental is $45. Okay, so let's go to 5 hours. Here's 5 hours. Is the canoe rental going to be 45? Yes. Okay, so for every 45, or for every 5 hours, it'll be $45. Okay. For 1 hour, meaning I'm over here, 1 hour, the canoe rental is $5. No. The minimum amount a canoe rental will be $20. Yeah, because that's my y-intercept. That's the minimum amount. Okay, sorry I confused you on that last one. But good work. Make sure you study and do well on that test. Good luck.